Hello. In 2029, I flew from Geneva in Switzerland to Minsk in Belarus. Then I flew from Minsk to Kiev in Ukraine. Then I stayed 3 days in the Chernobyl exclusion zone in Ukraine. And finally, I flew back to Switzerland. And the question is, what exposes you to more radiation, 3 days in Chernobyl or the flights? I measured it. With me, I had a radiation detector that was measuring and logging 24/7. And when I got home to Switzerland, I extracted the CSV file. This is how it looks like, and you see that you have these. Let's do it with the mouse. That you have the 5-minute intervals, and it counts the pulses that occur within those 5 minutes. And I wrote a Python script that analyzes those data. First of all, I put some labels on it for those 4 sections of my trip. Then I converted the pulses within 5 minutes to the equivalent dose rate, which is in microsievert per hour. And I also cumulated the radiation because I wanted to know what radiation I got in total. And this is how the graph looks like, which I done in Matplotlib. You see the 1 week of my trip, and the lower graph you see how it cumulates. And the problem is here, first of all, we see some background radiation. You always have background radiation, so this was correctly measured. And we see some spikes, but those spikes have only been to my radiation detector, but not to me. So this is the spike from the baggage scanner in Geneva. This is the spike from the baggage scanner at the metro in Minsk. This is the spike from the baggage scanner at Minsk airport. And here we had 2 spikes from the baggage scanner in Kiev airport. So I wanted to get rid of all those data, and when you do the data correction, it looks like this. Now you see that the background radiation is 0, and that you see that I removed those spikes that are not relevant to my body. This is how the source code looks like in Pandas. You see I have, these are the spikes of Geneva Airport, Minsk Airport, and Minsk Metro. And then in order to get rid of the background radiation, I calculated the median. And then I subtracted the median from everything, and again I calculated the dose rate and the dose in microsievert per hour. And finally, I created a very nice multiplot where you can see the 3 flights in particular and in detail, and you can see the 3 days in Chernobyl exclusion zone. And this is the interesting graph I want to show you. And here you perfectly see the 3 flights. You see perfectly how the plane goes up and comes down again. When you are at the travel height, which is around 10,000 meters, as you all know, the radiation is around 3.5 microsievert per hour. And on the bottom, you see the 3 days within the Chernobyl exclusion zone. We were exploring Pripyat, ghost town, and on the 3rd day, here's the landscape, the rural area, and on the 3rd day, we were in the nuclear power station itself. And you see, usually it does not go beyond 3.5 microsievert per hour, so it does not go beyond what you have inside an airplane, but you see some very few spikes. And you need to know the history of those spikes. Our tour guide showed us, look over there, there's a little particle that has excessive radiation. And then, of course, I put my device on it, and then it freaked out. And yeah, but as soon as you move 1 or 2 meters away, it's already gone. So this very excessive radiation was only felt by my radiation detector and perhaps by my arm, but not by the rest of my body. So to answer the question, the 3 flights I had during this trip, the sum of the radiation I got over there is the same as the excess radiation I got during the 3 days exploring the Chernobyl exclusion zone. Yeah, this is a Python conference, so it has to be Python related. I used a perfectly neat script, just using Pandas, Matplotlib, and Seaborn. This is me in Pripyat, proof that I was there. And this is the slide showing me that I'm thankful for your attention.
So it's not only me, as you can see, it's my colleague Rodrigo, and I'm thankful for him that he accepted the possibility to write some terminal things, and I'm not that good at it, so I will just present the idea. So we're at PyCon conference, so what do you think, what's the most Python way of consuming retrieving Python schedule? Let's see. Are we ready? Online? Yeah. So you do UV add PyCon Lithuania. Then you import PyCon LT. Maybe you get PyCon LT dot additions and call the additions. Like we're still struggling to figure out correct API on this. Then we call PyCon LT dot addition 2026 and then get the name, the dates, and maybe speakers, schedule. Yeah, so that's it. But be aware that the time is in UTC, okay? And the room numbers are just ID numbers and not the names. So, but you'll figure this out. Thank you.
So before going into the doc, tell me, raise your hands, how many of you have implemented linear regression in PyTorch? So few of them have done it. So today I'm going to talk about how to implement that same kind of linear regression from scratch using NumPy without using PyTorch. So you all might not know that what's happening inside that PyTorch linear regression because you all because it just uses because it hides all the internal. So let me walk through my code of linear regression from scratch using NumPy, which is similar to that. So here I've imported NumPy. Here I've initialized the X dataset and Y dataset array. The pattern is very linear. Just have to multiply the X by 2 and then you have to add and then you have to add 1 to it. And here I've used the learning rate as 0.1. And here I firstly initialized random M and random C, or random weight or random bias. You can call it anything. And here I'm showing the original slope and coefficient. And here I'm using the epochs as 50 times, and then here I'm getting the Y prediction, and then after that here I get the error. And here this is just to show that how much the error is decreasing, how much the loss is decreasing, and what is the epoch. So here I've used the MSE loss algorithm so that we turn that error into scalar average loss. And here I'm getting the size of the array, and this is the formula to calculate the gradient of D, and this is the form of M, and this is the formula of calculating the gradient of bias of basically gradient of C. And here I'm using the SGD optimization algorithm or stochastic gradient descent algorithm, which uses the formula of subtracting the weight with gradient multiplied by learning rate. And after 50 epochs, it will basically show the new updated MNC or weight or bias, and then after that it will show the prediction. So let me run the code. See, it worked. So first, so let me show you all the logs which so let me show you the output. So these are the original slope and coefficient which it selected randomly 3 and 5, which PyTorch also does it and initializes it underneath. But and here I have used the epochs. So here see it's decreasing the since epochs are increasing and the loss is decreasing. And then after that here it calculate, and then after that here it found the new M and new C, and then after that it showed the prediction which it could do afterwards. So this linear regression is actually project is similar to that PyTorch linear regression. This can be implemented in PyTorch. The only difference is that it is implemented from scratch and it shows all the math of it. Thank you.
Okay, hey everyone. I'd like to present you local Python config. What is it? Well, let's start with configuration in YAML files. Do you have configuration in YAML files, for example? Please raise your hand. Just curious. I see that. That's quite a lot of hands. Yeah. What And yeah, and also please raise your hand if you love Python. Okay, I like that. I also do, and sometimes I really wish that documentation was in Python. So this is what the talk is about. I would like to present to you how to have documentation in Python. Yeah. So how do we do it? This one way to do it. For example, we can have a config local file, config underscore local.py file. We can have it in the gitignore file, so it's not committed to Git. So it's on my machine. Or it's, for example, can be in production, can be in the staging environment. So it's environment dependent and not in Git. And for example, in the config.py where I have all my config, for example, I'm sending a very important report to very important stakeholders, and I have the email there. And yeah, when I develop, when I test, I definitely don't want to send my test version to the stakeholders. So this is why in that config underscore local.py I have just my email there. So yeah, and I can do this try and import this file. Yeah, and if it's imported, then it will override that, and the email will be sent to me only locally. If the file is not there, we can catch this exception, this error, and just say the pass. So it's okay if the file is not there, our program will not fail. So that's the safety part. So this opens a lot of possibilities. Everything that we can do with Python, for example. Okay, I will show perhaps later. Okay, now, so we can use just using one method here, just having the multiple very important persons. I duplicated the same email, but I wanted to do it 1, 2, 3. Yeah, and we can just wrap in quotes, do split, for example, to generate an array, a list. Yeah, and besides emails, we can do everything else that can live in configuration. For example, passwords. I can have the local password in the config underscore local. Yeah, and I in the code I can still have the. Okay, I suppose. Yeah, definitely the production password will not be in the main code of the program. Yeah, but still we can still use this approach. Yeah, so just wanted to share with you this way how you can use Python for configs and having the local config has its pros and cons that I could go through, but I will not go since this is a short talk. And yeah, thank you for the attention.
Thank you very much.
So, my topic, made with AI, nothing manual. Let's talk about the main problem, what I was experiencing when I was in data analytic, engineering, then transitioned myself into AI engineer, finished my bachelor's in AI and robotics, but didn't found any related job in Klaipėda. It was a big problem for me, but I started to grasp the data as a layer of building the foundation of AI. So my daily motto is learn something new every day. 7+ years of experience of mix of AI and data. And today I will be discussing how many of you are using BigQuery still as a data analyst? Raise your hands, please. No hands? Oh, some. Okay. So I really love Google products. Yeah, don't judge me, but I struggled myself as a data analyst with building our architecture, wrote SQL queries, raw one, scheduled them, and then put them into the tables, scheduled again, put into the views, connected with the Looker Studio or Power BI or Tableau, you name it. And it was really pain when I'm looking back at that points. We had not got any Git, so how to version this code, who deployed this SQL query. You go to the SQL scheduled queries, you check the logs, but it's not really useful. I tried to even get the API of the BigQuery and do the just request to not go through the manual work. I need a custom pipeline, so I just go into there and not into using the manual of UI. So what's really a pain, and you can feel it, was nested pipelines. So you do the query, you schedule it, you get the table view, you do the query again, and that's a lot of tree to go from, and how to onboard the new person that is just fresh. You just look at the tree and okay, without documentation, I can't even explain to the person that this is how our pipeline is working. And many companies that I worked in using BigQuery, and it's really hard to build something that you just need to automate this stuff, and I can't even just so what I do now is as my side project, because I still track my data, financial data, etc., etc. So what I do now is just I'm using Cloud Code, like some of you, or Codex, and what I did is just custom skill agents that has create a dashboard, create a view, create a pipeline, just get the data from the Looker dashboard, post in Slack, Telegram, etc. You can do this very easily and satisfy the business with their needs and values, because they are constantly pressuring you to deliver this fast. And why you couldn't deliver this fast? Because you've done everything manually. So that's a key takeaway. And what alternative approaches you can use? Of course, DBT, and like Uncle Data has said, everything you can do in DBT. There's things like that. And but my key approach, if you want no limitations, just use Python and forget about all the problems for the business. So yeah, that's it. Thank you.
So let's talk about art. This is the painting Night's Watch by Rembrandt, who's hanging. It's hanging in Amsterdam National Museum, and it's his magnum opus. It's best picture he created. And actually, this picture almost ruined him. He died in poverty, alone, and sad. This probably you don't know is by Van Gogh. This is the Starry Night. Is also magnum opus. Van Gogh was also very disappointed with it, and he spent his life in self-doubt, trying to get famous, trying to get recognition, and eventually ended his life by suicide. So let's fast forward to contemporary art. So this is the rabbit sculpture by Jeff Koons. Jeff Koons is most paid living artist currently. These sculptures are selling for millions. This is the art by Banksy. This artwork self-destructed itself after being sold for £1 million. Later it was sold for £18 million, 18 times more. And this is my favorite. This is by Joseph Beuys. He was invited to sculpture in Sculpture Festival in Münster to create a sculpture for the city. What he chose to fit some underpass with tallow and fat. And it was his statement of modern art expression. And now these chunks of fat are stored in Berlin in museum, and also his magnum opus. So what happened? First of all, photography appeared. So the art lost its function of creating and reproducing reality. So artists became like they started finding new areas and new styles, and like surrealism, cubism, impressionism, etc., etc. Also, it became more and more available. There were thousands of graduates each year, so the market is filling up. It's more and more difficult to get attention. That's why we're resorting to these like performances and viral campaigns to get famous. Also, it went even further when the cameras became widely available. Like in 70s, 80s, you still had to like learn how to take photography. Now it's everywhere. And it also increased it even further. Now we have all meme culture and viral culture in the internet, which also could be treated as a sort of art. So why do we talk about art? It's Python conference after all. Yeah, so it used to be simple in the software world. When I was starting my software career, we had all those open source projects, and basically those were heroes of the software world. So if you wanted to contribute somewhere, you had to be really talented and really strong, like Rembrandt and Van Gogh. And it even didn't matter, but they would accept your contribution. So what happens now with this generative AI, the development gets democratized. Like the whole community is exploding with new ideas and new stuff, and the same pattern repeats. So we have Moldbook, which appeared like a couple of months ago. It was hailed like some like new place for agents and bots to exchange ideas. Apparently, it was like most of those posts were meme posts or trolling by the humans. It confused a lot of people, including the Karpathy himself, who hailed it at first, and then it says it's just like a troll. So again, another project, Malus. So it hails itself as a clean room as a service. So we provide a service where if you have an open source project which has this restrictive licensing like GPL or something, we can recreate this with AI and basically create you a copy of it which is not entangled in licensing, and you can use it in commercial software. And actually I saw this on the podcast, and the guy who was presenting actually bought this service. We cloned one of the repositories, provided the service, but once you look into the responses on the site itself, it's clearly a troll. It's like Chad stockholder, Heinrich offshore, etc. And then in the recent news, we have Mila Jovovich, which probably some of you know from Resident Evil and Fifth Element, Hollywood actress and a celebrity. So she claims that she also created a system for AI memory, an open source GitHub repository. Again, things are still developing. Some people are saying it's genuine, some people are saying not. It's actually, the post is genuine, it's on her Instagram, it's on her social media. How much it's her job and how much it's just hiring a Hollywood celebrity to promote the GitHub repo, it's a different question, but still we are living in the times where Hollywood celebrities are promoting open source projects, which mind-blowing. Thank you.
Wow, nice.
Yeah, it was like my presentation. It was about us. And here it is like introduction, how I introduced myself. So here I simply, do we have voice? Okay, maybe we even do not have voice, but it doesn't matter. It is like video made, using Python. I will show you. So it's about us. Why about us? We are sitting here. Okay, so I will show you right now. I will exit this. It works. So I will show you just Python code. It is like done yesterday night or today very early morning. So code is not like maybe perfect, but here, you see the same. Yes, the same picture. So what we can do here, we can simply move everything around, so you can see, I can turn around, etc. And question, if I connect, to satellites, are we seen from cosmos, from the Earth, so let's see, how it goes. Still we see, ourselves. Oh, sorry. Continue doing this. Yes, we still see PyCon Lithuania. Oh, 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 we already near moon. Yes, so that's it. So it'd be like that was my presentation. Here, my LinkedIn page. You see many animations here. If you like. So it's up to you. If you want to connect me, I am fine with that. And that was my presentation.